with respect to time. A good morning or a good afternoon or a good evening to Mr. Akshay Kanwar sir. I am Mehul Sharma of ECE IV SEM. Now we will jump straight into the introduction. So before going to the main topic, I just want to talk about what is analog communication. So we will not go thoroughly, but just through definitions. Analog communication. It is a data transmitting technique in a format that utilizes continuous signal to transmit data, including voice, image, video, electrons, etc. An analog signal is a variable signal continuous in both time and amplitude, which is generally carried by the use of modulation. So here you can see an example, a difference between a digital and an analog signal. Here you can see a guy in front of the camera and the information is sent through the TV station and then received through a satellite box and then to the TV. But in analog you can see a guy in front of a mic maybe, and his information is sent through a wire to the amplifier and then to a record, and then a record again played through amplifier and then through the wire played through the speakers. So we can clearly see that in analog communication there is a need of medium for the traveling of signals, but in digital there is no need. So there are some advantages of analog communication as well. No quantization error, require less bandwidth, low cost and can be easily constructed because of less pre-processing requirements, a method of storing, processing and transmitting information through the use of distinct electronic or octal pulse that represent the binary digits 0 and 1. Disadvantages of digital communication which analog communication overcomes, which are path loss, fading, interference, Doppler shift. So we straight jump into the topic, modulation and why we need modulation. So before going to the why we need modulation, we must know what is a modulation. So in a simple words, it is a process of converting data into radio waves by adding information to an electronic or optical carrier signal. Here is a diagram to show how a baseband signal is converted into a modulated signal. So here the signal is sent through a baseband signal and then sent through a modulator, and then it is converted into a modulated signal and then through the RF power amplifier and then through the antenna. So we must know what is a baseband signal first. So a baseband signal is an original transmission signal that has not been modulated or has been demodulated to its original frequency. RF oscillator. An electronic oscillator is an electronic circuit that produces a periodic oscillating electronic signal, often a sine wave or a square wave. Power amplifier. A power amplifier is a type of electronic amplifier that converts a low power radio frequency signal into a high power signal. Typically, RF power amplifier drives the antenna of a transmitter. So the question arises, why do we need modulation? So before jumping straight into the definition, I want to show here an example. So the example says, if you want to transmit a signal through the free space and the frequency of the signal is 3 kHz and therefore the wavelength is 10 raised to 5 meters or 100 km. From the basic of antenna, there is a relation between the size of antenna and the wavelength of the signal. That is, the size of antenna is directly proportional to the wavelength. And since the wavelength of the signal is 100 km, so it becomes impossible for us to design an antenna of that size. And hence, to overcome this problem, we came with a solution called modulation. So here is a diagram to show how the modulation is done. Here you can see a message signal and a carrier signal, and in the third part you can see there is a merge between a message signal and a carrier signal, which result in an amplitude modulated signal. Here you can see a minimum amplitude and there is a maximum amplitude, and there is a large difference between a minimum and a maximum amplitude. So here comes some advantages of modulation, which is reduction in the height of antenna, which we have so here we have come to the advantages. The first is reduction in the height of the antennas. We have discussed it before in the example. Next one is avoid mixing of the signals. Third is increase the range of communication. Fourth is improve the quality of reception. These advantages, there is also advantage that multiplexing is possible, and multiplexing is It is a process of transmitting multiple number of signals through a common channel. And why it is needed? When many signals or channels are to be transmitted, then from transmitter side that sends simultaneously, that is multiplexer, converts many into one, so that at the receiving end also all input we get simultaneously. Sending many signals separately is expensive and requires more wires to send. So here you can see, if you send through many signal, it will cost your budget, and it will also cost your time for the setup. You can see, by sending through many signals separately, it can be very expensive for your pocket and it will require more time. So through modulation, the multiplexing is possible and it can come very handy. So after this presentation, I want to thank Mr. Akshay Kanwar sir for watching this presentation, and may you have a good day. Thank you.